transformer stress tests highlight grid reliability risks. The rapid build-out of renewable energy and battery storage is shifting attention to a critical yet often overlooked piece of grid infrastructure, the power transformer. As inverter-based resources expand and grid events grow more complex, the durability of these components is becoming a growing concern for utilities, developers, and grid operators. GameChange BOS, the transformer arm of GameChange Energy Technologies, recently completed dynamic short-circuit type testing for one of its high-capacity inverter-duty transformers. The tests were conducted at the Central Power Research Institute (CPRI) facility in Bhopal, India, and focused on evaluating how the company's 17.6 MVA 5-winding transformer performs under extreme electrical stress. The exercise is part of a broader industry push to ensure critical equipment can withstand increasingly volatile grid conditions driven by the rise of inverter-based generation and large-scale renewable projects. Stress testing transformers for severe grid faults. Short-circuit faults represent one of the most damaging events electrical infrastructure can encounter. When they occur, sudden spikes in current can generate powerful internal forces inside transformers, potentially deforming windings, damaging structural components, or triggering wider system disruptions. To evaluate the durability of its design, GameChange BOS subjected the unit to dynamic short-circuit testing at CPRI's specialized facility. The transformer endured 9 asymmetrical short-circuit shots at 100% of the requested current, each lasting 0.25 seconds. The test sequence is designed to simulate the extreme mechanical and electromagnetic forces produced during real-world grid disturbances. Testing followed multiple International Electrotechnical Commission (IEC) standards. Electrical measurements were taken before and after the test sequence in accordance with IEC 6076-1 to verify performance stability. The program also included dielectric testing under IEC 67763 and sound level checks based on IEC 6076-10. After the testing was completed, the transformer was untanked and inspected internally to verify that no structural damage had occurred within the core, windings, or supporting components. Designed for inverter-heavy renewable systems, the transformer tested is an inverter-duty transformer (IDT), a configuration developed for renewable energy plants, battery energy storage systems, and other installations built around power electronics. Unlike conventional generation assets, inverter-based resources can introduce different electrical stresses into the system. Multi-winding transformers are often required to integrate several inverter outputs into a single grid interconnection point. At the same time, transformer availability has become a growing constraint across global electricity markets. Utilities and developers have reported extended lead times for large transformers as renewable deployment accelerates and grid modernization projects expand. GameChange BOS says its manufacturing platform is intended to help address this supply gap. The company reports current production capability for transformers up to 138 kV and 50 MVA, with plans to expand to designs reaching 345 kV and 300 MV. Demand for medium-voltage transformers has already increased as developers rush to secure equipment for projects tied to tax incentives and interconnection timelines. According to the company, more than 190 medium-voltage transformer orders have been placed, partly driven by developers seeking to meet safe harbor requirements and diversify supply chains amid Foreign Entity of Concern (FEOC) restrictions.